Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So, continuing to the previous video, in this video again we will see the derivation of torsion of an arbitrary section beam of different time. That's why I just mentioned here the second. Okay. So, lecture topic is derivation on torsion of an arbitrary section of different type. What are the possibilities are there? Differentiation, that will be derivation for that. So now just see this one. Now based on this, same numerical also will be there. That's why I just mentioned here numerical on torsion. So don't get confused with this one. That is the derivation, and with that derivation they will give some value that you have to put. So if directly numerical is there, then no need to derive this one. Simply you can write whatever the formula we will derive, and last we know that this is the formula, and substitute the value and solve for the answer. That's all. No need to derive. Okay, if they ask the derivation, then only you have to derive. So that's why I just mentioned here numerical on torsion. So based on this, the numerical also will be there. Right. So make sure either they ask numerical or given values. If given values, then simply use the formula and substitute the value, get the answer. If not, then derive that one. Okay. So now just see. An open section beam of length L has the section shown in figure. Right here, that is the figure. Okay, the beam is formally built in at one end and carries pure torque T. That we are deriving itself built in at one end and pure torque T. Derive expression for the shear, that is mentioned here. Derive. So derive expression for the direct stress and shear flow distribution. So we have to find here two things: direct stress and shear flow distribution produced by axial constraint. Right, that is what the sigma T and QT system, and the rate of twist of the beam. So here the rate of twist also is required. Right, that we have to find. Question is given like this one. So what is given here? 1 to 2, 2 to 1 to 2, 2 to 3, 3 to 4. This is the beam is there. Right. Now what we have to do, the same way we have to take some AR value, that again wrapping is 0. So just assume here that AR is here. This is AR, not that wrapping. After that, at 0 wrapping, what will be the AR? That is here. So it's not necessary you take 1 to 2. If you wish, you can take from 3 to 4 also. And from where we are starting? From this center point. Okay. So this you can start, and this you can take image like this also. Right, means you are starting from 3 to 4, not 1 to 2. That is the same. So it's not necessary that always you have to start from 1 to 2 only. So now, and then in question also this is given that height of this is given like 2 to 3 is h, 1 to 2 the distance is d, and 3 to 4 distance is d. Means these two are d, okay, and this is h. Now shear, that S is acting here what, from 1 to 2, and here they given thickness also. Thickness of this is what, T, that is 2 to 3, but not 2 to 3, that's for all. That thickness is 1 to 2 also thickness is T, 2 to 3 also thickness is T, and 3 to 4 also thickness is T. Means that uniform thickness is there. Now we have to derive what, the direct stress and shear flow distribution formula. So now what we will do, we will just redraw this one, or you can say we will take the projection of this one. Right. Let's see how. The beam is loaded by a pure torque so that the axis of twist passes through the shear center. Then only no other torsion will be there. If that won't pass, then some other torsion also will be there. Means that is SR, shear center. So here, what? This is shear center. That load should pass through that axis should pass through the shear center only. We shall take the origin for S at the point 1. And initially plot 2AR naught against S to determine TR. So what we did, from S taken as origin, and then for 1 to 2, right? This one has taken as origin, and then found that AR value, that AR naught. For this case, as I mentioned earlier, this is not necessary. You can take for this one, that time you can find AR naught for 3 to 4, and then your 4 will be the reference point or origin. Okay. The position of center of gravity, that is 2AR dash of the wire 1 to 3. So now instead of this equation, right? So see what we have. like this is there. So 1, 2, 3, 4. Now just bend like this one, right? So then what happens? This will come up, right? This becomes a straight. So now I am writing just this one, right? So here this is 1, 2, 3, 4 according to this, or you can just flip that one. Then this we can write as 1, 2, 3, 4, but not. Whatever the distance from here to here will be there, that will be 2. Here, this will be 3. From here to here, what is given? That as D. From this to this, what is given? That height as H. And from this to this is given D. So, what will be then? Then we will take this as 2 dash, 3 dash. And same point is coinciding. So, 1 dash and at 4, right? That will be 4 dash. So, at 4, it will be 4 dash. Okay, so now just we are changing this figure to this figure. So I'll show you in next slide how that is there. Just see here, 1 to 2, 2 to 3, 3 to 4. That is what? 1 to 2 D is given, 2 to 3 H is given, and 3. Now their projection is 1 dash to 2 dash. Let's just see 1 and 1 dash is coincided. 2 dash to 3 dash. 2 dash, 3 dash is not equals to 2, 3. Don't remember, right? That is not necessary, but in this case it's just look like a rectangle. Then it's a 2, 3 will be equals to 2 dash 3 dash, but 1 to 2 never will be equals to 1 dash 2 dash. So don't get confused with 1 2, and that 1 dash 2 dash will be the same, right? So of the wire 1 dash 2 dash 3 dash 4. Now what we will do, instead of the previous figure, we will find according to this one. Is found by taking moment about the S axis. Okay, then so this is 2AR naught versus what? That S. Okay, that is the diagram in that same. So from here to here, this is 2AR dash, and this is what? 2AR. 2AR is what? 2AR naught minus AR dash. So here this is 2AR naught. From here to here is 2AR naught. This is 2AR dash. So this difference will be 2AR. Okay, that already we know that one. So let's apply. So what we are taking moment about S axis. So taking moment about this one, right? So now T into 2D plus H into 2 dash AR. That is just moment means what? Force into perpendicular distance. So your distance will be 2AR dash. That is equals to T into D, right? Into HD by 4. Just see here. That HD by 2, where it will act half of that one. So this will be HD by 2 means HD by 4. So for that it will act HD by 4 plus TH into HD by 2 plus TD into HD by 4. So I mean for TD, right? For this one, that will be HD by 4, right? From which now here just see this is there. If you will multiply and simplify, just expand this one. So let's see what you are getting. So after multiplying this part, I am just reading. So TD square H, right? After multiplying with TD square H by 4 plus from here T H square D by 2 plus here T D square H by 4. So TD square H by 4, TD square H by 4, what we will get? T D square H by 2 and plus T H square D by 2. So what we can take here common? That HD. So after taking HD common or T also, T H D common. So what is left here? D by 2 also I am taking common. So D, and here it will be H. Right, so just see a numerator. D HD into H plus D by 2. Right. This side what is that? 2D plus H. Right. So now this we can write this as this one. So instead of all these things, what we can write this. So this is T into 2D plus H into 2A dash R. Okay, is equals to what? T into HD by 2 into D plus H. Right. This T cancel. But we are finding 2AR dash. So 2A dash A is equals to what? Simply this will get divided here, right? So that is equals to HD by 2 into D plus H, and this is 2D plus H. So this will be the 2AR dash value. So this here, this is the 2AR dash value. Tau R follows from the moment of inertia of the wire about an axis through its center of gravity. Right? This follows from the center of gravity. Hence, now tau R is center of gravity means what? For a triangular, it will be 1/3. For rectangular, it will be at half of that one. So for first part, the triangular part, okay. So that is 2 TD into 1/3 of HD by 2 whole square, plus for the rectangular part, this is TH into HD by 2 whole square, minus what we got, this one, 2AR dash, okay, whole square into T into H plus 2D. So now just see here, if you will see, a square is there, everywhere a square is there, but here these two are there. But first simplify this term. So HD, right, into H plus D whole square divided by this. So 1 square with this H plus 2D will get cancelled. Only T will left. After this here, right, I take T common here. So once we multiply this one, this will be H square D square by 4. So after multiplying, this will be 2 and 4 get cancelled 2. So by 1 by 6. Okay. And then simply after multiplying here, TH into H square into D square by 4 minus same this way. So after expanding and simplifying, okay, and taking common, you will get T dq H square by 12 and into 2H plus D by H plus 2D. After expanding this one, or wait, let me expand this, then it will be more clear. Okay, so I'm just expanding term by term, right? So this will give you what? 2T D 1/3 into, after squaring, this will be H square D square by 4, right? So this two becomes 2, or just keep this one 2 also, 4. So what we will get? 2T dq H square by 12, 4 into 3, 12, right? So we will get 2T dq H square by 12, okay? So this term. Now plus, so this is the first term. What we will get from here, this is TH into HD. So H square D square into TH. TH into H square D square by 4. After multiplying, what we will get? T HQ D square by 4. Okay. So from here. Now after simplifying this, H plus D, H plus 2D is there. And so this one will get cancelled. After multiplying this, just expand or just see here. H plus D, H plus D. If you will keep common and then just expand and take the C here, what you have to take common? T dq H square by 12. After taking common, here just see in this term it's a 4 is there, so that term will get multiplied by 3, and once you will subtract with this one, that will be 2H. Okay, so like after expanding this also, you will get tau R as this one. Okay, so now from the total torque equation, just now we derived, right, that equation that in previous video we derived this one. So that is the total torque. Just use the total torque equation. So the total torque equation is what? That Saint-Venant and Wagner torsion equation, right? Just sum of those two. So this is T equals to Gj d theta by dz minus E tau R dq theta by dzq. May now be solved for d theta by dz. So now we will solve for here d theta by dz. Okay. Rearranging and writing mu square as Gj E tau, Gj by E tau R we have. So for this, we are just assuming this one. So now what we have, okay, so mu R square is this one. So just replace there. So here, that is not there, right? So what is here? T is there only, right? So from this, what we can write? T by Gj. So here, or just divide with ETR. Simply E tau R divide with all the term. So this term will be dq theta by dzq. Okay, or just let me show you. So T is Gj d theta by dz minus E tau R dq theta by dzq. q. Now I'm dividing with e tau r through all the tau. So t by e into tau r, okay, this one, right, that is tau r, okay, that will be there, is equals to g j by e tau r into d theta by dz, okay, minus this will get cancelled, dq theta by dz q, okay. Now just make this as making this as positive, okay, so just multiplying minus all the sides, or just here let's put this one, t by e tau r, right. From here just see what is mu square. Mu square is g j by e tau r, right. What we have, tau by etr. Etr is what, mu square by gj. So sorry, e tau r is from here gj by mu square, right, or simply that by this. So after putting here e tau, now put that value. So tau by e tau r. E tau r is what, gj by mu square, that is equals to minus. So this is minus, minus, and this is plus, is equals to e tau r. So this is gj by mu square. So j by gj by mu square into d theta by dz, this is minus, and plus dq theta by dz q. So now this what happened, this will come up. So minus mu square t by gj is equals to minus gj cancel, mu square d theta by dz plus dq theta by dz q. That is here, just here. dq theta by dz q minus mu square d theta by dz is equals to mu square t by gj, right. So after simplifying this, we got this one. Now this is one differential equation, right. So differential equation solution will require what power is there, 3 power, means 3 term will be there, right. So see, the solution of equation 3 is of the standard form, that is d theta by dz equals to, up to the second level only we are, right. Okay, so up to the second only. So d theta by dz is equals to d theta by dz is what, t by gj, whatever the constant of this is there, right, plus a cos mu h, because here mu is the function, right, and theta mu. So a cos mu z plus b sin mu z. Now what we have to do, we have to find this constant value a and b, and then we will substitute here by using the boundary condition, and then we will get the value of d theta by dz, and that only d theta by dz will be the rate of twist, right. So in previous video also we can see the derivation, that rate of twist they can ask. So rate of twist is d theta by dz. Now we require to find a and b. So how we will find a and b? By applying the boundary condition, right. So now let's apply the boundary condition and just see what we are getting the value of a and b. Here the constant a and b are found from the boundary condition, okay. So at the built-in the wrapping w is 0, since w equals to minus 2ar d theta by dz, that already we had seen, that is the formula, then d theta by dz is 0. So that this term is 0 for first condition, right, at built-in condition. At the free-in, sigma is 0 as there is no constant and no externally applied direct load, therefore from equation 27.1, thus again this today for that one, equation 27.1 is from chapter number 27. What is that? d2 theta by dz square as 0 at the free end. Just apply the boundary condition. So here d theta by 0 for first boundary condition, then what we will get from here, one equation, and second one, sigma is 0. So after finding that, what we will get, a equals to minus t by gj, that is this term, okay. So this will be 0, that z is 0, z is 0 means what, mu into 0, 0, so a cos h 0 means that will be 1, so that is a into 1, right, or just let me put here itself. When z is 0, so I am putting that value 0, and d theta by dz also is 0, so 0 equals to t by gj plus A into cos H mu into 0 plus B sine mu into 0. Mu into 0 is 0, sine 0, 0, right? So this whole thing 0. Mu into 0, 0, cos 0 is 1. So T by Gj plus A into 1, that is equals to 0. So from here A equals to minus T by Gj. So now we have the value of A. Okay, so A equals to minus T by Gj. Next, now for this one, finding B, still B is left. So here this is theta versus Z. So at Z equals to L, that boundary condition we have to use. Theta is what? Tz by Gj. From where? That Saint Venant. That already just we used that one, right? So just to see this one, this is a stiffening effect of axial constant. Now from equation to B equals to what we will get? T by Gj into tan H mu L. Why? So just see here, I'm showing you. That is given here. Okay, now we have the value of A, right? So we will substitute here. Okay, and what is given? D theta by dz, that is d2 theta by dz is 0. So differentiate once again the given equation. Okay, and then substitute. So just here d theta by dz after substituting finally. So first we need to find B. Okay. So here from this equation, that is for when that z is equals to L, that we had seen in the second one. So when z is equals to L. So now what is there? D theta by dz equals to T by Gj plus A value we found. What is that? Minus T by Gj. Right. So I'm putting my plus of, so minus is T by Gj into cos mu z is what? L here. Okay, plus B sine mu L. This we have to find. So from here we require to find B. Just equate 0. Then this will come this side, right? Take Gz by common here because Gz is not there. So after solving, what we will get? That B equals to T by Gz. So that is just here sine by cos. Sine is negative, so sine H by mu L by cos H by mu L, that will give you tan H by mu L. Hence B is equals to T by Gj tan H mu L. Now we have A, B, just substitute the value. So d theta by dz, where you will substitute? Here. Right, A we found B. So now put here. So d theta by dz will be tau by Gj. A is minus tau by Gj, A cos, that cos H mu Z, and B we just found here. So after substituting, we will get d theta by dz equals to, taking T by Gj common, 1 minus cos mu Z plus tan H mu L sin H mu Z. Okay, this further we can simplify d theta by dz as T by Gj common. So 1 minus cos mu H, right, into L minus Z, cos A minus cos B formula. Right, so after dividing this, we can write as sin H by cos H. So taking LCM, then we can just solve for this one. That will be cos of A minus B. Right, so cos of mu into L minus. So this is cos A minus cos B formula. Right. I'll just see. That formula is what I'm just writing here. So this term I'm solving first. Cos mu Z plus tan mu L I'm writing. That is sine, that is H is there. Sine H mu L by cos mu H, or H mu L. Okay, into sine mu Z. So just taking LCM. So this will be cos mu H L into cos mu Z, right? Plus this is sine H mu L into sine H mu Z. Cos A, cos B plus sine A, sine B. Right. That will give you what? This one. So just see, after taking minus common, this is cos of A minus B. So which one will be A? That L. So cos of L minus H, and here mu will be there, that, and divided by this term. So divided by cos H mu L. So see here, this cos H mu L. Okay, so d theta by dz will be equals to tau by gj into 1 minus cos of mu into L minus j by cos H mu L. Now just see, if suppose they will ask simply derive, right, then you can leave up to this itself, that is rate of twist, yes, this one. But in question, if they will mention like derive this one, then next step you have to do cos of A minus B formula, and then you can show this term. So again, that depends on what they are asking the question. In simple word, if they ask find the rate of twist or derive the equation for rate of twist, you can stop here also, or simply further you can, this is the simplest form of this one, so you can. But if suppose they will mention directly this, derive this one for rate of twist, or derive rate of twist is equals to this one, then if suppose they mentioned here, then you cannot stop here. If you will stop here, means you will reduce the marks. So for that you have to derive up to this one. If they are not mentioning, then this one is fine. The first term in equation 4 is seen to be the rate of twist derived from St. Venant torsion. So here T by Gj after multiplying, right? So that is from the St. Venant torsion theory. Okay. The hyperbolic section term is therefore the modification introduced by the axial constraint that equation 4 may be integrated to find the distribution of angle of twist theta. Now whatever is here, just integrate this equation, right? Equation 4 may be integrated to find distribution of angle of twist theta. Appropriate boundary condition being theta is equals to 0 at the built-in, that is 0 to that L you have to integrate. So theta equals to T by Gj into 1 integration is what? X, right? Similarly, dz integration is z. So z sine mu L minus H by mu cos mu L minus sine mu L by mu cos mu L. So this will be the theta. And the angle of twist theta Fe at the free end of the beam is theta Fe is TL by Gj minus the into 1 minus tan H mu L by mu L. So this will be the theta at what? Free end. That Fe stands for the free end. So theta at free end will be TL by Gj 1 minus what? Tan H mu L by mu L. Okay. So this will be the theta at free end. This is the theta, that is the angle. What is that? Rate angle of twist. Just see the difference. If suppose they will ask find the rate of twist, means you have to derive either this or this one, rate of twist. If suppose they will simply ask angle of twist, means just integrate the rate of twist, then this will be the theta value, that is angle of twist. If suppose they will ask theta at the free end, that angle at the free end, then this will be there. So from here again 3 or 4 different type of question can be formed. Derive the equation what? At the free end. What will be the for theta at the free end? Means you have to derive up to this. Derive the equation for what? Angle of twist. Then angle of twist you have to derive up to this one. Derive the equation for rate of twist. Then rate of twist means either this or this you have to, because this is a simpler form of this one. So that you have to up to this. So means 3 derivation can be asked from one single derivation. So don't get confused. Read the word and up to that derive properly. Okay. Now the decrease in the effect of axial constraint towards the free end of the beam is shown by the examination of the variation of St. Venant, that is to say, and Wagner T torque along the beam. That already we had seen. That first term is that St. Venant and second term is the Wagner one. So T J will be equals to Gj d theta by dz. So after putting that is equals to T into 1 minus cos mu into L minus z by cos H mu L. Right? So T tau will be what? That already we derived this one. So just put the value. So after putting E, that is tau, T tau is equals to minus E tau r dq by d theta. After substituting, what we will get? T is equals to cos H mu into L minus z by cos H mu L. Simply this T minus term will get removed for T tau, because that is the what? Venant torsion. Okay, so again, just you can refer mention for this one. So if you have any doubt, okay, you can just, so here just see, instead of doing this one like this, they can give question directly like this also, right? If this type is there, then how to solve that we will see in the next video. So don't get confused, see the concept, what actually concept is required and for what we have to find, right? That you have to find. Don't confuse with the question. Oh, this question is there with that question, how I will solve with the other question. Same, just you have to see what is the concept, d h d, what is given, then you have to take the moment, those things, and then just simplify that one. You will get the equation. Okay, so just again, this is the moment, taking moment about the reference. After moment, just expand this one, simplify, find 2AR dash value. Once you have 2AR dash, then what is required? Tau R. Tau R again, you will get from here. So from there, after simplifying this, we got tau R is this one. Okay. Now we know from the total torsion theory that tau is Gj by Gj into d theta minus E tau R dq by d theta. So now solve for d theta by dz. So here what we assume that V mu square is Gj by E tau R. Right. Just replace here, and I saw you already solved how to get this one. So after getting this one, this is the differential equation. Solve the differential equation. Solution of this differential equation is here. T by Gj A cos mu h B sin mu z. Now what we have to do? We have to find A and B, that constant value. How we will find? By applying the boundary condition. So first boundary condition is what? D theta by dz is 0 when z is 0. Just put that one. You will get the value of A. So after putting that, what we got? A equals to minus T by Gj. Okay. Then second boundary condition when z is equals to L. Right. So apply that second boundary condition at here, z equals to L, and theta is Tj by Gz. Apply that one. Right. After that, B is equals to what you will get? T by Gj into tan mu h. Now substitute the value where? In the rate of twist equation. So after that, finally you will get this one. Further you can simplify, right? D theta by dz is T by Gj into 1 minus just cos A minus B formula, and you will get this one. So this is the equation of rate of twist. Now angle of twist is required, then simply integrate that one. You will get the angle of twist. Next, angle at the open end, or the angle of twist at the free end is equals to what? TL by Gj into 1 minus tan mu L by mu L. Okay, so this will be the angle at the free end. Okay, then next, that just combination of both the torsion, that center end is tau j is what? Gj d theta by dz. So put the value of d theta by dz. Okay, so T by, let's see here, that this one, T by Gj, right? Or here, after putting this d theta by dz, right? We have to put d theta by T by Gj into this term. So Gj already is there, Gj cancel, right? This Gj will cancel, so only this will be there. So this is what? Saint Venant. This is tau TR is what? That Wagner one. Now total will be, total T will be equals to what? Tj plus T tau, Saint Venant plus Wagner one. Just add these two equations. That will be the total torque. Okay, so that if you are required to find the total torque, just simply add these two. Okay. So if you have any doubt related to this, again you can just contact me or comment on the video. I will clarify that doubt. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.